Good morning, students. In the last period, we have seen about the types of buffer solution. In that, acidic buffer solution, basic buffer solution, as well as we have seen the properties of buffer solution and the applications of buffer solution. In the applications, the buffer solution is find various applications in the biochemical system as well as in the agriculture, in the industry, in the medicine, in the analytical chemistry. These are the various sectors in which the buffer solution plays an important role. Now today we will see about the solubility equilibrium. Solubility equilibrium. In this, hereafter we are confined our attention to the primarily soluble compounds. That is, compounds though dissolve only slightly in the water. The solubility equilibrium हे पाहत असताना आपल्याला काही महत्त्वाच्या गोष्टी आपल्याला या ठिकाणी लक्षात ठेवणं आवश्यक आहे. Suppose that some powder primarily soluble salt such as AgCl is put into the water and stirred vigorously. A very small amount of AgCl dissolves in water to form the saturated solution, and most of the salt remain undissolved. Thus, the solid AgCl is in contact with its saturated solution, and the AgCl is strong electrolyte. Hence, the quantity of AgCl that dissolves in water dissociates completely into its constituent ions, that is Ag plus and Cl minus ions. म्हणजे असे काही कंपाउंड्स जे आहेत जे की पूर्णपणे पाण्यामध्ये डिसॉल्व होतात. फॉर एक्झाम्पल वी हॅव टेकन हियर दॅट इज द AgCl, powder form of AgCl, which is when it dissolve into the water and stirred vigorously, at that time some part of that AgCl dissolves and forms the saturated solution. But most of the part of AgCl, it is undissolved, and that undissolved part of the AgCl is in contact with the saturated solution of AgCl. And at that time, the quantity of AgCl that dissolves in water dissociates completely, that is AgCl, it dissociates into the ions Ag plus Cl minus ions. या AgCl चं डिसोसिएशन आपल्याला या पद्धतीनं Ag plus आणि Cl minus ions या पद्धतीनं झालेलं आपल्याला आढळलं. Thus, equilibrium attained is the called as the chemical solubility equilibrium, and this is represented as Ag gives Ag plus and Cl minus ions. And the expression for its equilibrium constant, the equilibrium constant K is equal to molar concentration of Ag plus into molar concentration of Cl minus ions divided by concentration of AgCl. That is, the equilibrium constant K is equal to molar concentration of Ag plus into the molar concentration of Cl minus divided by molar concentration of AgCl. Suppose that this is the equation number 1. Then the concentration of undissolved solid AgCl is constant, and we may write that is the concentration of AgCl undissolved solid is equal to the constant, that is the K. And this, substituting this value into this equation, the K will be equal to the concentration of Ag plus into concentration of Cl minus divided by K dash. Then K into K dash is equal to काय होईल हो? K into K dash is equal to molar concentration of Ag into molar concentration of Cl minus. हे इक्वेशन आपल्याला या ठिकाणी आहे. Where K into K dash is the another constant which is called as the solubility product. ह्याला काय म्हणतो आपण? Solubility product असे म्हटलं जात असतं. K into K dash. And that K into K dash is equal to solubility product. And this solubility product is denoted by Ksp is equal to molar concentration of Ag plus into Cl minus. And this for the general solubility equilibrium, that is Bx Baxy Ba x y gives the B x the exponent y plus y a to the exponent x in the aqueous medium. And this aqueous medium, the solubility product is Ksp, that is the solubility product, is equal to molar concentration of B y plus ions to the exponent x into A x to the exponent y, and that is the solubility product Ksp. This in this equation, in the saturated solution of sprangly soluble salt, the product of equilibrium concentration of the constituent ions arranged to the power equal to their respective coefficients in the balanced equilibrium expression at a given temperature is called as the solubility product. म्हणजे ही जी solubility product जो आहे, आपण sprangly soluble salt आपण या ठिकाणी कन्सिडर केला. कोणता? तर AgCl हा sprangly soluble salt आहे. When we have taken the example of this AgCl, when it dissolves into the water, only few part of the AgCl will dissolve into the water and it forms the saturated solution. But most of the AgCl is undissolved, and that undissolved AgCl is in contact with the saturated AgCl, and this AgCl dissociates into the Ag plus and Cl minus ions. Then the expression for the equilibrium constant K is equal to molar concentration of Ag plus Cl minus divided by AgCl. That will be the equation 1. But this AgCl, undissolved AgCl, is equal to the constant, and that is represented by the K dash. Then put this value into this equation. Then K is equal to Ag plus Cl minus divided by, instead of AgCl, we have taken the K dash. But the equation भेटल्यानंतर काय होईल? K into K dash is equal to Ag plus Cl minus. But this K into K dash is nothing but it is the solubility product, and that solubility product is represented by the Ksp. Hence, the Ksp is equal to Ag plus Cl minus. Then for the general solubility, general salt solubility equilibrium, हे जनरल इक्वेशन जे आहे ते आपण या ठिकाणी पाहिल्यानंतर ह्याच्यावरून आपल्याला असं म्हणता येईल की in the saturated solution of sprangly soluble salt, the product of equilibrium concentration of the constituent ions raised to the power equal to their respective coefficients in the balanced equilibrium expression. That is the at a given temperature is called as the solubility product. अशा पद्धतीनं आपल्याला हे प्रायमरी सोल्युबल सॉल्टचं हे इक्वेशन सॉल्युबिलिटी प्रोडक्टच्या बाबतीमध्ये आपल्याला येतं. देन द रिलेशन बिटवीन द सॉल्युबिलिटी अँड द सॉल्युबिलिटी प्रोडक्ट. आता या सॉल्युबिलिटी आणि सॉल्युबिलिटी प्रोडक्ट मधलं जे इक्वेशन जे आहे हे इक्वेशन या ठिकाणी आपल्याला पाहत असताना काही बाबी आपण लक्षात ठेवणं हे गरजेचं असतं. That is the relation between the solubility and solubility product. Relation between solubility and solubility product. In this, the solubility of a compound is the amount in grams that dissolves per liter per unit volume is called as the solubility. Solubility म्हणजे काय? जिथे एखाद्या कंपाउंड पर युनिट वॉल्यूम मध्ये किती डिसॉल्व होतो that is called as the solubility. Means the solubility of a compound is the amount in grams of dissolve. It dissolves per unit volume, which may be the 100 ml or 1 liter of its saturated solution. म्हणजे 1 लिटर पाण्यामध्ये किंवा 1 लिटर सॉल्व्हेंट मध्ये तो जो कंपाउंड जो आहे पर युनिट वॉल्यूम जर आपण म्हणतो 1 लिटर असेल किंवा 100 ml असेल याच्यामध्ये पर युनिट वॉल्यूम मध्ये किती कंपाउंड तो डिसॉल्व होतोय ते म्हणजे त्याला सॉल्युबिलिटी असं म्हटलं जातं. अँड द मोलार सॉल्युबिलिटी द नंबर ऑफ मोल्स ऑफ कंपाउंड that dissolves to give 1 liter of saturated solution is called its molar solubility. म्हणजे molar solubility is nothing but it is molar solubility is equal, it is the ratio of solubility in gram per liter, solubility in gram per liter to the molar mass in grams. Molar mass in gram, that per mole, that is the molar solubility. For example, consider once again the solubility equilibrium, that is BaXy. आता आपण पर कन्सिडर केलं किंवा BaXy, it gives dissociate Bx to the power y plus A y to the power x. That the solubility product is given by the equation, that is the Ksp is equal to the molar concentration of Bx to the y plus into A y to the x minus. या इक्वेशन मध्ये आपल्याला हे सॉल्युबिलिटी प्रोडक्ट, इफ S is the molar solubility of the compound, the equilibrium concentration of the ions in the saturated solution is given by that equation, then these are the relation between the solubility and the solubility product is equal to Ksp is equal to S into S, that is the S square, that is the solubility and solubility product. हे इक्वेशन जे आहे हे इक्वेशन आपल्याला पाहायला मिळतं. देन व्हॉट आर द कंडिशन्स फॉर दिस द solubility and the solubility product. या काय कंडिशन्स आहेत? कंडिशन्स ऑफ द precipitation. The ionic product IP of an electrolyte is defined in the same way as solubility product. The only difference is that the ionic product expression contains the concentration of ions under any condition, whereas the expression of KSP contains only the equilibrium concentration. If ionic product is equal to KSP, the solution is saturated and the solubility equilibrium exists. If ionic product is greater than the solubility product, then the solution is supersaturated, hence the precipitation of the compound will be occurred. And if the ionic product is smaller than the solubility product, that is the KSP, the solution is unsaturated and the precipitation will not occur. म्हणजे ह्या तीन कंडिशन दिल्या आहेत. एक कंडिशन IP is equal to first one, ionic product is equal to ionic product of solubility product. If IP is greater than KSP and IP is smaller than KSP, म्हणजे ज्यावेळेस हा ionic product of is equal to the KSP, the solution is saturated and the solubility equilibrium हे adjust झालेला आपल्याला. आणि दुसरी कंडिशन काय असेल? when IP is greater than the KSP, at that time we can say that the solution is supersaturated and hence the precipitation of the compound will be off. And in the third case, the IP is smaller than the KSP. At that time we can say that the solution is unsaturated and the precipitation will not occur. In this way, हा या ठिकाणी आपल्याला हे कंडिशन्स जे आहेत प्रिसिपिटेशनच्या ह्या पाहत आहेत. Then the common ion effect. The common ion effect states that the ionization of weak electrolyte is suppressed in presence of strong electrolyte containing and common ion weak electrolyte. Common ion effect कशाला म्हटलं जातं? तर the common ion effect it states that the ionization of weak electrolyte is suppressed. But ionization of weak electrolyte is suppressed म्हणजे थांबवलं जातं. That when in presence of strong electrolyte containing common ion to weak electrolyte. म्हणजे for example, consider the solution of weak electrolyte, weak acid, that is the acetic acid CH3COOH. At that time, this common ion effect, in this case, suppose that the weak acid CH3COOH will be taken in a consideration. At that time, the ionization will be CH3COO plus minus plus H plus. हे ions त्याचा dissociation झालेला आपल्याला आढळून येतो in aqueous medium, and when the another, that is the CH3COONA being a strong electrolyte कुठला आहे? CH3COONA. The strong electrolyte, when it is in consideration, then it dissociates into this CH3COONA will be dissociates CH3COONA will dissociate CH3COO minus plus Na plus. Then this will be equal. Both the acids and the salt produce CH3COO minus ions in the solution, and therefore it provides the high concentration of CH3COO minus ions. And high concentration of CH3COO minus ions, and according to the Rjcl principle, principle, the addition of CH3COO minus ions have shifted the equilibrium of dissociation of CH3COOH to the left hand side, and hence thus the reverse reaction will be favored, in which the CH3COOH will be formed as the acetic acid CH3COOH. The reverse reaction, in this case, the CH3COO minus plus H plus ions reverse to the CH3COOH. It will be formed, and thus the dissociation of CH3COOH is suppressed due to the presence of this CH3COONA containing the common ion CH3COO minus. This is the common ion effect here we have seen here. Now we will continue in the next video. Thank you.